Find the solution set to the inequality x squared minus 2x minus 3 is less than 0. One way to proceed on solving this problem is to temporarily treat this inequality as an equality. In other words, take your less than 0 and replace it with equal 0. Now, if you did that, you would then be interested in solving for x for this equality, and that will help us find the solution set for this inequality. So let's just proceed with this problem just like it was saying solve for x, and then we'll come back to the original question in a minute. So in this case, the first thing we'd try to do is factor this if we could, and if we can't, then we would move to the quadratic formula or completing the square. So because there is an x squared right here, we put an x here, and we put an x there. And because we have a negative 3 right here, what we can do is we can put a 1 and a 3 in these positions. Now the last step is to figure out whether this should be plus and minus or minus and plus. And because we have a negative 2x up here, this should be a plus and a minus when it is factored. Now, because we have one thing times another thing is equal to 0, that means either the first thing, that is the x plus 1, is equal to 0, or the second thing, which is the x minus 3, is equal to 0. This first equation can be solved for x by subtracting 1 from both sides. When you subtract 1 from the left-hand side, you get x equals negative 1. And when you solve this equation, you want to add 3 to both sides of the equation. When you add 3 to the left-hand side, you get x. When you add 3 to the right-hand side, you get 3. So it turns out our two solutions are x equals negative 1 and x equals 3. Now at this point, there are two ways to proceed. And in both ways, we are trying to figure out on a number line which values of x will satisfy the inequality. But we have found two very important numbers, which are negative 1 and 3. And I'm going to go ahead and label both of those numbers. Here is the number negative 1. Here is the number 3. And in the second way of proceeding, here is a negative 1, and here is positive 3. So using our factorization here, I'm going to rewrite the original inequality here as x squared minus 2x minus 3 is less than 0, can be written as x plus 1 multiplied by x minus 3 is less than 0. Now, in the two different ways of solving this particular inequality, one of which we're going to do over here, and the other we're going to do over here, you'll get the same answer either way. But the first way exploits the fact that this thing right here is a polynomial. If this happens to be a polynomial, we can use things called test points. And the way test points work are, if you can find any test point between negative infinity and negative 1, if a test point works in there, it will always give you the same result. So let's try a test point here. Let's try, let's say, negative 2. When I plug negative 2 into both of these, what do I get? I get negative 2 plus 1, that's a negative 1, and I get negative 2 minus 3, that's a negative 5. Well, negative 1 times negative 5 is positive 5, and positive 5 is not less than 0, and because of that, the inequality is not satisfied anywhere to the right of negative 1. So that's the first step. Now the second piece is, because again, this is a polynomial, this only works when this is a polynomial, you can take any point between negative 1 and positive 3. Now the easiest value to plug in is this point right here, which is 0. So when I plug a 0 into here, I get a 1. When I plug a 0 into here, I get a negative 3. 1 times negative 3 is negative 3, and in fact, negative 3 is less than 0. So it turns out that inequality is always true at any point between negative 1 and positive 3 because it worked at our test point. Finally, let's go out and try a test point to the right of 3. An easy one to choose is 4. So let's plug 4 into the inequality. 4 plus 1 is 5, and 5 multiplied by 4 minus 3, which is 1. 5 times 1 is 5. 5 is not less than 0 because 5 is a positive number, so it is false on this side. And so these are the values where the inequality is satisfied. Now you have to check the endpoints as well, that is negative 1 and positive 3. When you plug in a negative 1 here, this becomes 0. And 0 is not strictly less than 0, so this endpoint does not get included. And likewise, over here with 3, what you do is you plug 3 in here, and you get 4 multiplied by 0, which is 0. And 0 is not less than 0, so that point is not included. And so as a final answer here, you get all of the x values that lie between negative 1 and positive 3. Now that only works because you have a polynomial. Here's another way of approaching it. Think of it this way. For any point that is to the left of negative 1, let's just use an extreme one like negative 10. Well, this is going to be negative multiplied by another negative number, and a negative times a negative is a positive. So all of the points to the left of negative 1 are out. How about points in between negative 1 and positive 3? Well, any point that is in there is going to give you a positive here and a negative here, and a positive times a negative is a negative. And in that particular case, it does work, so we'll thicken the line in there. And then finally, for the last piece, what you have is if you take a point that's out here, let's just take positive 10 way out here. Well, for positive 10, this is going to be a positive value. This will also be a positive value. A positive times a positive is not a negative. So in this particular case, the final answer, for the same reason you exclude the endpoints, you'll get the very same answer, which is negative 1 is less than x is less than 3. That is the solution set to the inequality which is given here.